Welcome to VW 2.2. Today we're going to continue our study of complex numbers and we're going to get to do some pretty challenging examples here. So first, we'll start on our first one. Notice how the powers of I are quite high. So if you recall our table here, if you have I to the first power, that's simply I. I squared is -1, I cubed is -I, and I to the fourth is 1. So for problems like this is what you really have to have down in your head. And again, we can call this like powers of I. The key for you is you want to highlight this one right here. I to the fourth is 1, which means we're trying to generate multiples of 4 in there. So if I look at this first term, 4i27, I'm going to rewrite that as 4i to the 24th, and then times I to the third. So notice how this makes 27 here. And I do that because this thing, this I to the 24, because that's a multiple of this thing, I can just cross that out, and that becomes 1. So we're going to do that process for all of them. So plus 3, so think about 125. 124 would be the biggest power of 4 in there, or the multiple of 4, and that has 1 I left over. And 28 is nice because that's already good, so we can leave that alone. Next one we have 6 plus 2. So think about 53. The largest multiple of 4 in 53 would be 52. And then there'd be 1 left over, minus 5, and then I to the 80 times I. And again, if you're wondering how I made this thing 1, think of I to the 24th. You can think of it like this: I to the 4th to the 6th power. So that makes it more apparent. This is 1, and 1 to the 6th is still 1. So all of these I to the power multiple of 4, these cross them out, they're 1. Now we simplify. So I have 4, but notice how you have I cubed here? Look at your chart. I cubed is -I. So that's going to be -4i. Then we have plus 3i minus 2, all divided by 6 plus 2i minus 5i. So notice how the problem becomes significantly easier now. Let's rearrange it. -2 minus I over 6 minus 3i. We're going to multiply by the conjugate now to simplify. We'll continue our work here. So our numerator, we multiply this out, that's going to be -12 minus 12i plus 3. The bottom should be 36 plus 9. And that's going to become -9 minus 12i, all divided by 45. Now again, a lot of people want to stop here, but notice how it says a plus bi form. That means we have to separate it. So we separate and reduce. -1/5 minus 4 over 15i. So that's our first example.
This next example says, solve for x in a complex number system. Write answers in standard form or a plus bi. So I'll just note that really quickly, a plus bi. Notice how there are 4 terms equals 0. So let's do what we normally do. Highlight the first 2, highlight the second 2, and let's factor it by grouping. I'll take out the x cubed, that's x plus 1. Take out a -1, that's x plus 1. And now look at that, x plus 1 times x cubed minus 1. So already this is a good sign. I can see that's going to be one solution, so I'll leave that alone. I can factor x cubed minus 1. That would be x minus 1 times x squared plus x plus 1. And already I can see these two things are going to generate 2 answers. x is already going to be 1 or negative 1. Now for this thing, make sure you highlight this. Whenever you get quadratics like this that are normally not factorable, because we're in the complex system, we're going to use the quadratic formula to solve. So x should equal opposite b plus or minus the square root b squared minus 4, a times c is 1, all over 2a, or 2, negative 1 plus or minus the root of negative 3, all over 2. We're going to rewrite that thing right there. Negative 1 plus or minus root 3i over 2. And now we're just going to put these together. 1, negative 1. And make sure you make a note to yourself. I'll use red here. Must separate this fraction. And that's because we have to write them in standard form, which is right here, a plus bi. So now we have our final answer. 1, negative 1, negative 1 or 2, plus or minus root 3 over 2i. Circle that. And let's move to our final example.
One of the roots of a quadratic with integral coefficients is 6 plus I root 5. Write the quadratic equation in the form ax squared plus bx plus c equals 0. So this is basically writing the equation from an answer. So the best technique we have is going to be reverse complete the square. And if it gives you 6 plus I root 5, if you want, you can rearrange that. Some books write it like this. If it looks better to you, just write 6 plus root 5i. So if this is an answer, then we know 6 minus root 5i must also be an answer. So to do reverse complete the square, I can just write x should equal 6 plus or minus root 5i. And let's just do the method. Subtract the 6, square, that's x squared minus 12x plus 36. That should equal negative 5. And look at that. There is our answer. So pretty much the same thing we did in our last chapter. Okay, so good luck on the homework questions and bring your questions to class.